Yes. Now it is clear.
Yes, sir. So, what are the weightage of the quiz atom?
What are the weightage of
Weak-wise content in the atom?
weak-wise content in the atom? Week 9, 10, 11 has the 40% weightage. Okay. Then week 1 to 8 is the 60% weightage. Okay.
How many questions will be there, sir?
Mm, Total 5 questions in the atom.
In 50 marks paper.
Now shall we start with the week 8 content? Week 10 content. So week 10 content is basically related to the battery management system. Okay. That is basically the, we can say this is the main important subsystem. So the battery management subsystem, not system. Battery management subsystem. That is very important because the work of this battery management subsystem is only not only to provide the supply, not only to provide the supply voltage, but it also have the balance power. It is also have the working of charging a battery. Okay. Now, if we are talking about the balance power, so meaning of the balance power is if any subsystem, like we have a subsystem one, subsystem two, and subsystem three. So with every subsystem, the required voltage is different. Maybe possible. Required voltage for power is different. So to manage this thing, manage this different power is the main work. Okay, manage this different power or manage this balanced power. Why balanced power? If the power delivered is greater than the required power, two particularly issues are there. One, heat up that will damage subsystem component. And second, discharge the battery even faster. Discharge the battery even faster. So these are the two particular problems when we deliver the power. Now, for this uh, condition, we required a LDO. LDO is low dropout voltage level. Okay, low dropout. So this is the only solution for this. Now, if we say that we have a power supply and due to this power supply we connect one load with the impedance Z, and with this particularly Z we connect a microcontroller, and that is the heart of the subsystem. Okay, heart of system. Heart of system. Basically controller of system. Okay, controller of the system. Every particular system that which operation will be performed, what is the power required of that one, if that particularly feature is not used, so what is the power consumption of that one, reduce the power consumption, reduce the voltage, so all the things will be managed by the microcontroller. Okay, like for example, if we are using a mobile phone, like for example this game we are using the Wi-Fi connectivity. Okay, so every time if we are using this particularly features of the mobile phone, the battery drainage is very fast. Okay, and when I am not using this one, my battery drainage is slow. So that particularly will be managed by the microcontroller. That this subsystem is required, which subsystem is useful. According to this one, the power consumption will be changes. Okay, so all this thing will be managed by the microcontroller. That is the basically heart of a system. If my screen is required, so according to this one, the power consumption is different. If screen is not required, Wi-Fi is not required. Okay, so all particular things will be done by the microcontroller. Now, if this power supply will provide a constant voltage, that means no issue. Okay, that means no issue. But the thing is that this constant voltage is not possible. Ideally, the constant voltage is not possible. Why? Because power supply is nothing but a battery. Okay, and with the use of battery, with the use of battery voltage reduces. Okay, if battery voltage is reduces, this particularly constant voltage is not possible. This particularly constant voltage is not possible. So what we do, we are required a regulated. Okay, we are required a regulator. That regulator will manage the thing that if there is some variations in the power supplies, so after the this variation in the power supply, it will be providing me the constant voltage. Okay, it will be providing me the constant voltage. So that particularly will be done by the LDO, low dropout voltage levels. So basically, to provide a constant voltage, regulators is required. Okay. Now these regulator is classified into parts. One is the One is the basically switching regulator. And second is the linear regulator. Okay. In the linear regulator, the voltage is always same linear. Voltage is linearly regulated. Okay, in the switching regulator, the voltage is regulated till the subsystem is in use. Subsystem is in okay. Subsystem in use. So if we are saying what is the difference between the linear regulator and switching regulator and which one is the right? So like for example, I am talking about the linear regulator. This particular linear regulator is providing constant voltage to subsystem even though providing constant voltage subsystem even though subsystem is not engaged. Subsystem is not okay. Where the switching regulator is providing me the constant voltage only the duration where subsystem is in okay when subsystem is in use. Okay, so it will be providing me the constant voltage either my particularly any subsystem or any component will be idle. Okay, and in the switching regulator, it will be providing me the constant voltage till it is in use. When it is idle, they will drop down the voltage. Okay, so there are two types of regulators. Now, as we can see that switching regulator is the complex. Switching regulator is complex. So LDO is linear regulator. LDO is a linear that will be providing me the constant. Okay. Any doubt? Now, for the LD or for the regulators, linear regulator, some parameters are very important. The first is input voltage range. Second is typical output voltage. Third is output voltage range. Fourth is output accuracy. Next is line regulation. Then load regulation. And last one is the strength. Okay. The line regulation unit is the millivolt, and this unit is the voltage accuracy is percentage. This is V stainless current is the milliampere or microampere. Generally, the microampere is used for analyzing the micro. Okay. Okay. So these are the some parameters. Along with that, there are two parameters, but that is not too much important. One is the load current, not too current, load voltage, short. So these are the some parameters that is calculated for the linear regulator. If these parameters on the basis of this parameter we identify our linear regulator is a good regulator or not. Okay. So we can calculate this particularly to any system. Okay, now we are saying V in to the V out to R1. Now V in is basically the battery. Okay, whereas the minimum is 3 volt, the maximum is 4.2 volts, and the typical is 3.6. Okay. Generally, we are using the battery resistor. Now, first is the input voltage range. So, input voltage range is generally 3 to 4. Okay. Now, what is the output voltage? What is the output? V out is what? V in into R2 by R1 plus R. So that means if V in is 3 volt, so 3 R2 upon R1 plus R2. 2 if V in is 4.2 volt, so 4.2 R2 upon R2. Okay. So my V out is range is from 3 into R2 upon R1 plus R2 to 4.2 into R2 upon R1. Okay. Now if we know the value of R1 and R2, like for example the R1 is 160 kilo and R2 is 150. So R2 upon R1 plus R2. So if we know this what is the value of R2 upon R1 plus R2 is equal to 140 divided by 3. So what is the range of output voltage? 3 times 140 to 4.2 into 150 divided by 2. So it becomes 1.4. So this becomes a 1.4. What is the value of this one? 48 times 4.2 is 0.14 times 14. So it is a 2.5. Okay. So I can see my output voltage is 1.4 to 2.5. Okay. Now, sorry, this is the output voltage. This is the output voltage. Now, with respect to the typical output voltage, so in the case of typical output voltage, it becomes for the typical output voltage, it is a 3.6 into R2 upon R1. So it is a watt. If you are calculating this one, so it becomes so it is a 1.68. So the typical output voltage input from the 1.4 to 1.96. The typical is 1.68. Okay, so we can calculate. Now, what is the accuracy? So basically, accuracy is what? if R1 has the value of R1 and R2 has the value of R2, so we know that V out is R2 upon R1 plus R2 times V. Okay, we say that this. But as we know, in particular resistor, we have a four bands, and the fourth one band is basically the plus minus. Okay, fourth band is nothing but the plus minus. So if we say that the value of R1 is nothing but R1, it is a R1 plus delta. Similarly, the value of R2 is R2 plus delta. Okay, because of the fourth band, third band. So the value of R1 is nothing but R1, it is R plus delta R1, and the value of R2 is not only the R2, it is R2 plus. So if the resistance value will be changed, if the resistance value will be changed, we know the output voltage is also changed. So if I am using this R1 and R2, so my V out is not only the V out, it is a V out plus delta. Why? Because if the resistance value is changed, the output value. Clear? Okay. So V out plus delta, V out is nothing but R2 plus delta R2 upon R1 plus delta R1 plus R2 plus delta. This one my output voltage is now changed. Okay. Now can I take a R2 from the numerator and R1 plus R2 from the denominator? So this is the V out plus del V out is equal to R2. I'm taking from the outer side, upper side, and R1 plus R2 from the. Okay. So for the remaining term is what? At the numerator it is a 1 plus delta R2 from R2. And if I just use this term, so I can write as a 1 plus delta R1 plus delta R1 plus R2. Okay, so the V out plus delta V out is this. Now how can I solve this one? So V out plus R R times 3 in V out plus delta V out. Can I write it as 1 plus delta R two from 1 plus delta R plus delta R. I am taking this term as a delta power is so V out. Now if I multiply this, it becomes 1 plus delta R2 from R2 minus delta R2. If you have any doubt, you can ask. If you have any doubt, you can ask. We can say like this one, this term is minus delta R2 multiplied with delta R1 plus delta R2. Okay. Now, if I consider delta R upon R plus so if it is a delta R1 upon R, similarly delta R2 upon R2. Okay, so this multiplication term, because it is coming in the square form, it is coming in the square form. So when you multiply the delta R, so delta R will be the square form. Okay, so I can neglect this. I can neglect this. Okay, so this is the term. Now, if you see the if I multiply, so V out multiply with one, V out multiply by this one, and V out multiply. Here also V out. So can I cancel out this V out with this V out? Sorry, not. But with this one. Okay, because when I multiply V out with one is the V out. Okay, so I neglect this term, so it becomes a del V out. Now this V out is with multiplication. This V out and V out is this. So it becomes a del V out upon V out is equal to del R2 upon R2 minus del R1 plus del R2 upon R1. Okay, one will be cancelled. So we are not using this particular 1. 1 will be 1 plus del R2 upon R2 minus del R1 plus del R2 upon R1. Okay, 1 will be cancelled. So we are not using this particularly 1. 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 Now can I break into two parts? One is the del R2 upon R2 and second is the del R2 upon R2 minus del R1 upon R1. Okay. How can I simplify? Yes. So what should I do? I take a common of del R2 equals to R2 minus del R1 upon R2. So if I take the LCM, so this is the R2, R1 equals to 1 to del R2 and del R1 upon R2. Now remaining here is the R1, is the R2, is outside. Okay. Now here what is the remaining term? Is R1. So del R2 upon R2, the remaining is R1 upon R1 minus del R1 upon R1, R1. What should I do? I just convert it to del R1. Now del R1 upon R1 upon R1 plus R2. So it becomes the del of R2 minus del of R1. This is the del VR. Okay, so this is the formula for del VR. Yeah. Is there any doubts till now? So this is the output voltage. Now if we know the value of V1, R1 and R2, del R1, del R2, so we can calculate the output voltage. The unit is percentage. Now after that the line regulation. Okay, so after that line. So what is the meaning of line regulation is? Okay, so line regulation is what? If we change the voltage, input voltage by 1, if we change the input voltage by 1 volt, so what is the changes that occurs in the output? That is called the line regulation. Okay, so basically, what is the line regulation? The line regulation is change in output voltage when the input voltage change but the condition is that no load. Okay, when no load. So if we say that the we consider as a 2.2 voltage, now we consider as a 4.2 voltage in case the stress between the V out. With respect to this one, we are getting a V out voltage. So on the rest of resistance value, so if we say we have the 3.2, so V out is what? 3.2 into R2 upon R1 plus R. Okay, and second case when 2.2. And if we are talking about the 4.2 volts, so we have to want 4.2 into R2. Okay, so the difference between these two is called the. Now the next is load regulation. Is applicable for load. Okay, that means if any load is connected, so this particular load regulation will be taken. Why? Because this load regulation is a dependent parameter. It is dependent on the parameter of load. Okay, any doubts? So we can say the change in the output voltage when IL is changed from 0 to max. Okay. For example, this is my circuit R1, R2 out. Okay. So when no current will be following, that means there is no resistor. Okay, because if there is a resistor, there is a path, the current will flow. So if no current, so V out is V out is what? V in into R. And V in into R. Now second case is that we have a IL that is the max. I load that is the max. Suppose for example we say that 10 milliampere is the max. So in this scenario, my subscription is like that. That is the any value will be there, like for example 10 milliampere. Now let's say the so V is equal to 4.2 into 150 divided by 2,000. The second case, what will be happen if mm, 10 milliampere current is there? It is a 160 and 150K. So the drop across this particular resistor is what? Because it is behave this particular circuit will behave as a voltage source connected in the series with resistor. Okay, so we have V in 160K, 140K. The direction of current will be the ground. Now the value of this one is 140. Okay, because 140 multiply with 10 or any value actually. I am not saying that it is a 10 million. Any value. So it is a this one. Okay. Now if we apply here, so what is the value of current I? So I is nothing but V. Now this particularly 1400 is in series. So plus 1400 divided by 300K. Okay. So some value X is there. Okay, some value X is there. Like for example, we say that V is 5. V is the 5. So it becomes a 1405 divided by 300. What is the value of current? So it is a 4.68 million. So the current that is flowing from this particularly will be the 4.68. Now how many current will be flow up drop across this? 4.68 is the current that is flowing. So the current is 160 multiplied by 4.68. So that means the across this resistor, what is the drop? The drop is 748. So now, if 748.8 volt is already dropped across this one, so what is the output voltage? Yes, what is the output voltage? So the output will be of what? V in minus we get any value for the V. We can solve this way. Like first, we are considering no voltage, no particularly drop across the load. So no current will be flowing. If no current will be flowing, we have to take only parallel combination of R and R. Okay, after that, we will realize that if some amount of current will be flowing from that load, so may be possible that the dropout voltage is not a constant. Due to that. Okay, it will be. Now, how much voltage in this scenario, in the load situation, how much voltage we are getting at the output? We calculate this one in a way that first of all we calculate the current. Okay, after identify the color, we know that what I have to write. Okay, and finally we are getting the output. Now, initially, what is the output voltage? Initially, what is the output voltage? So when IL is 0, the V out is we are calculating as a 1.96. Now if IL is maximum, we are getting the V out is equal to V in minus 748. Okay, 748. So the difference in the output voltage. So what is the difference? So what is the output voltage? So del V out is equal to V out when IL is equal to max minus V out when IL is equal to max. So this particularly del V out is nothing but the load. Okay. The next parameter is the I think you are aware with one thing is that when you purchase any electronics product, say when you purchase any electronics product, so it says that kindly charge complete before using it. Have you seen this particularly statement where you are using the battery operated electronic system, electronic gadgets you are using? So in this it is mentioned that kindly charge completely before using it. Yes or no? Have you seen it?
Yes, sir.
So why this particularly is written? See why it is written? Because thing is the product that you are using has some shelf time. Some shelf time. What is the meaning of shelf time? Is if you are purchasing any product, you don't know that this product is when it will be available for out when it is out from the company, or basically when it will be charged, basically how much old it will be available in the market, how old it will be available in the shelf. We don't know this. Okay? So every product has a shelf life. If you basically, if you are a manufacturer, you purchase and you basically manufacture any product, okay, and you are going to sell a product, so you can't ensure that this product will be sale either today or tomorrow. Maybe it will be take 1 month, maybe it will be take 2 months, maybe it will be take 3 months or more than that. Okay, so you have to charge your product in a way that if your product will be sale after 3 months, there is some power is available. Why it is so? Because if you are going to sell a product after 3 months and your battery is drained completely after 1 month, so till 2 months there is no voltage. Okay, till 2 months there is no voltage. And if in 2 months there is no voltage, so we can say our charging rechargeable battery will be damaged. Our rechargeable battery will be damaged. It will be only working if you charge your battery regularly, or if there is some charge is available for the use purpose. Okay, if your rechargeable battery completely discharged today and you are going to charge after 10 days or 15 days, so your rechargeable battery will not charge. Your rechargeable battery will not. Okay, now the rechargeable battery costing is rechargeable battery costing is high. So if you are going to purchase a product and that particular battery is not working, so it is a basically a problem with the product. Customer will not purchase that product. So that's why we have to maintain a standby. We have to maintain a standby. The standby current is the minimum consumed current when your product or appliances is not working. Everything working condition but not in working. So this particular is the minimum consumed current any product. Appliances is not. Take for example, if we are going to purchase a watch, okay, smartphone. Okay, you don't know that particular watch will be available in the market at a rate before you okay, and if your smartwatch battery is completely damaged, okay, and it will not recharge more than 5 days, 10 days, 15 days, so your battery will be damaged. Your battery will be damaged. In this scenario, you have to replace your battery. Okay, you have to replace your battery. So this is the that's why the standby current is the important value. It will be dependent on the standby. It will be dependent on the standby. So if I say, like for example, I have a 500 milliampere hour battery, 500 mAh battery, that is 60% charge. That means overall current is 300 mAh. Okay. So basically, it is a 300 mAh charge level. Clear? Now, if I say I have to maintain a shelf time of 6 months. Okay, 6 months. That means it may be possible that my product will be available on a shelf for 6 months. No customer will purchase that product within 6 months. So basically, I have to maintain a shelf time of 6 months. So that means how many hours I have to maintain that. So 6 multiplied by the 30. Normally, in every month we are taking 30 days. Now with every day we are taking a 20. So that means standby current is 300 divided by 6 into 30 milliampere hour upon hour. So we can say what is the current? So that means 69.4 microampere current to the standby. Means till when product is not used, so your product will consume 69.4 microampere. Okay. If your product is not in working mode, it will be consumed 69 microampere. Okay. Now the thing is that why we require this one? Can we do it as a zero? Can we do it as a zero? Similarly, think again. I say if your battery will be charged, if your battery will be charged 100% and there is no chemical reaction will be done with this battery, or basically there is no drop of the voltage, no drop of the current. So after some time, your battery will damage. Damage of that means it will be not a rechargeable battery. Similarly, think if I consume a 0 volt, so again the current, no current will be there, no chemical reaction will be there, so my battery will be not in, no, not in use. So maybe there is chances that battery condition of battery has to be down. If you are going to recharge it, it is not possible. Okay, so this is the two scenarios. So that's why we are use we use our battery in a way that it will be chemical reaction will be going on if the product is not in. Okay, so that's why the standby current is important. Every product has a standby current. Yeah, every product has a standby current. Clear? Yes, any doubt? some product that is not 2 months used will maintain its shelf life longer than if some product is regularly used, we can basically go with the lesser shelf. And a similar example is that nowadays every particularly in India, if we are talking the every second there is a loss of mobile phone. So we know that my mobile phone, my product, if my product is good, so it will be safe within a 1 month. So what should I do? I just maintain it shelf life. If we are talking about the earbuds, okay, if I am talking about the earbuds that is used by the customers, okay, the demand of the earbuds is due to day by day. So I know that my earbuds will be safe within a 2 months of the use. Similarly, thing is that if I require it to if I want to sell it to the consumer is used very less. It is not a demanding. Persons use that one, but it is not demanding in a way that it will be when I basically go to the market, so everyone is basically considering that. So maybe I have to maintain a longer shelf life, a longer shelf life. So it will be dependent on the product that the product shelf time is more required or less. Okay. And on the basis of this one, I need to set the standard. Okay. Now, which parameters is remaining? Load current that we already calculated, load voltage already calculated, short circuit current. Okay, that short current is basically. So what should we do in the load current? We will do some circuit. Okay. I'm using one particular resistor, load impedance ZL, VL, and calculate the current. Calculate the R. Okay, that particularly IL is load. IL is. Now if I calculate the IL, what is the load voltage? Load voltage is nothing but IL multiplied by the ZL load voltage. IL multiplied by the ZL is the VL load. Now short circuit current. We will need R1, R2, arms my V out. What should I do? I just use the short circuit. Here we are now using the short circuit. So the current that is passed from this circuit. Okay. So we can say initially, if you are talking about the IL, so IL is nothing but what? IL is nothing but what? So it is a VI upon First of all, I just calculate the I is V I upon R1 plus R2 parallel with ZL. It is the I. So IL is what? I times R2 upon R2 plus ZL. Okay, I times R2 upon R2 plus. Now in this case, what is the I short circuit? ISC, that is nothing but V in upon V in upon R. The current that is passing from this R1, it will be completely passed with the short circuit path. It will not go towards the R2. Why? Because if we are taking the parallel combination of these two, so we can say the voltage, so basically resistance value is 0. Resistance value is 0. So there is no impact. Okay, there is no impact. The current will be passed from the path where the resistance. Okay, so these are the parameters. These are the important parameters for the selection of any load LDO, load power voltage regulator. So if you have any doubt, you can. Yes, if you have any doubt, you can ask. No doubts? Students, no doubts?
No, sir.
So these will be basically calculated. These are the parameters. Now after that, the professor discuss one LDO data sheet. I think that is the 24040. Preview 24040. Okay. And on the list of that one, they identify that basically they discuss the parameters, not the data set. They discuss the parameters for R1 and R2 is 5 and 5. R1 and R2 we are mixing up 5 ohm. Calculate this parameter and identify which parameter is okay and which parameter is required in minimum value or maximum. Okay, that means which parameter we have to compensate either the higher value or the lower value. So my LDO will be the better. Okay, my LDO will be the better. Clear? So these will be discussed further. Now, second thing is that we discuss I think one more thing. I'll do something. circuit also. But, so with the help of this circuit, if they are getting a 1 volt here, so what is the output voltage? V out is what? The 1 volt that means this is also. Can I say that this is the VX, this is the V out, and on V out, VX, VX, and VX is 1 volt, and 1 is that we can change the parameters. You can vary the parameter output. Okay. We can vary this parameter. Second thing is that with the help of this circuit professional where we basically change the line. We are changing the line everything. Yeah, so they have nine structures. Now in the next phase we design. But more structure is that either in case of negative and positive, I just use this is the negative. I use the negative. Okay, so in case of what we are doing with this, we are using working button. And we are using one inverting element. So basically, this is again behave as a negative bit. This is again behave as a negative bit. How? Because this MOSFET will be work as a inverting element. Okay. So if you remember what is the basic meaning of the inverting element, basically negative feedback is that if I talk about an A beta, so A beta should be negative. A beta is negative, it is a negative. In week one we discuss. Okay, so plus, but this one is a minus. So we can make it a minus. So plus multiply with minus and resistor are basically there is no polarity, okay, no changes in the polarity. So plus multiply with minus become minus. Okay, this terminal is plus, so we are getting a plus voltage here. Now this one is a minus, so we are getting a minus. Okay, so it will be basically change the. It will basically change the. But with this, there is one more problem. With this, there is one more problem. Controls. Now, what is the problem with this circuit? Is any idea? Any idea what is the problem with this circuit? Like this is the battery voltage. V is the battery. Now V out is the output voltage from the this particular system, and that particular output voltage will be connected with other subsystem. Any other system. Subsystem, I'm just saying the subsystem. Okay. Maybe it is a out of any we have discussed out of any subsystem. This is a single subsystem. Now the required voltage for this one, for this subsystem is 2.6. Okay. So when battery is having a 4.2 volts, we are getting a 1 volt here. Okay. If 1 volt is there, we are getting as a 26k and 10k. We are getting a 26k and 10k. So what is the output voltage we are getting? So with respect to 1 volt, V out is what? Minus RL by R1 into, okay. Why minus RL by R1? Because this is a non-inverting amplifier. Because it is a connected, the supply will be connected to the negative. Feedback is negative, but supply is also connected on the negative side. So the formula is minus RL by R1. Okay, and this because of this minus, because of this non-inverting, feedback is negative. Okay. So what we are getting here? We are getting here as a minus 2.6. Okay. I use some particularly inverter here to convert it to the 2.6. Yeah, I use a converter to get the. Okay. So if the battery voltage will be drop 3.6 volts, so the voltage at this point is around 0.86. Now this is a 0.86. What we are getting as the output? It is 0.8, so 0.86 multiplied by the 226. So it become around a 2.4, 2.4 or 2.2. 2.4 or 2.2 volts. Anyway, okay. Now this subsystem required a 2.6 volt. This subsystem required a 2.6 volt, but now we are getting a 2.2. So the functioning of this subsystem may affect. Why? Because if we are not providing the proper voltage, may be possible their functioning is not accurate, not a proper function. Okay, their function is not a proper function. So we require a 2.6 volt to the subsystem, but subsystem will Okay, because only one or basically minor change in the battery. So this is the problem. Okay, and if further battery voltage will be dropped down, so my subsystem is not working. But I can't say the battery is zero. There is battery, but subsystem is not. Okay, subsystem is not working. Why? Because it is not getting a correct output, correct required. Okay, so what we do in this case, we have to maintain this. Okay, we have to maintain this voltage. So if we want that subsystem to work effectively with voltage at this point will not reduce it will not reduce. No. Yeah. This. Any doubt? So what should we do? We are using a band gap reference. We are using a band gap reference. Now, what is the meaning of band gap reference? Any idea? We are using a band gap. Any idea what is the meaning of band gap reference? Have you used this particularly? Yes, you use this one in the week 3. If you remember, in the week 3, there are the combination of diode circuit is used. Combination of diode circuit is used. That is band gap reference. Okay, like for example, if you remember that we calculate the VD1 and VDN. Okay, and difference is VDN minus VD1. So you are getting the voltage. Okay, so you are using a multiple diode combinations to get a constant voltage. Okay, constant voltage. And for this one, we already discussed in the video. There is a negative temperature coefficient is there. Okay, so you have to add a positive temperature coefficient with there. So it will be basically cancel out this. So you are getting a constant voltage. You are getting a constant voltage. That's okay. So that's it in the week 10. Okay, and it's if you have any doubt, you can ask. In the next class, we discuss the battery design of week 10. Okay.
Excuse me, sir.
Yeah.
Sir, I have a doubt in week 9 assignment graded.
Week 9 assignment question number 1, 2.
Yeah.
Okay. Basically, the answer is different. I
Yes,
don't know
yes.
why it is. you see, I can show the answer sheet. So the answer for the first question is 2.98, and answer for the second question is this equation. With this equation, you can calculate the value. Okay.
Yes, sir. I got the same answer.
Yeah. The answer is 2. Okay. First and second question will be reviewed. Any other doubts?
No, sir.
Sir, can you explain weekly experiment circuit once?
Which one?
Weekly experiment.
Week 3 experiment. Today 9. There is a class, no? Session, no?
Sir, actually, like the TAs are not explaining the circuit, they are just picking up the questions. So if you can once basically tell like what are we trying to do in that circuit?
You have to check the circuit.
Sir,
Yeah,
so what is the highest marks in quiz 2?
100. Yes. So basically the edge-based driver and integrations. Okay. So basically, what is the meaning of edge-based driver? Yes. Edge- So you are. So you have to design HP's driver and the integration. So what is the purpose of this circuit is that wherein we use the HP's driver. If we want to change my voltage is meaning that the change in the polarity. Like for example, for a second I want to provide a plus 12 volt, and for a second I want to provide a minus 10. Again, another second we require a plus 12, minus 12 in this way. So only change the polarities of the signal. We require a H-bridge circuit. Okay, like if you are aware with the robots. Okay, robots, in the particularly robots, one IC is used for the motor is that is the L293D. Okay, L293D. So basically this L293D is the HP's driver IC. Okay, so every time what will be provide, because my motor will be working in the clockwise and anti-clockwise direction, so we have to switch the voltage. One time it is a plus 12 and one time it is a minus 12. So in the plus 12, if it is moving in the forward, minus 12 it will be moving in the backward direction. Okay, so I have to control my motor in both ways. So that's why I want to switch my supply. Okay, and that particularly will be done by the H bridge. Okay, now this H bridge is nothing but a combination of we can say that it is a combination of transient not a transient, it is a now it is called the, I think you are studied about the stable. Okay, differential amplifier, you have aware about the differential amplifiers. You are aware about the differential amplifiers, or some particularly you can say the multivibrators. Yes, anyone? You are aware with the multivibrators of the differential amplifiers? So basically the circuit, if you see here, this circuit is nothing but it will be providing me the two outputs. One is the Q and second is the Q bar. Okay. So in this particular two situations will be appear if any of the one transistor, basically any of the one gate will be having a high voltage with respect to this one second, the second particularly gate will be providing me the low voltage. So basically it is providing me the two coupling output similar to the flip flop. Okay, similar to the flip flop, it will be providing me the two different outputs. Now we can use this particularly output for the PWM generation. PWM is what? A pulse width modulated signal. Okay, the width of that particularly modulation pulse is dependent on the charging and discharging time of the capacitor that we connected here, C. Okay, this C. So on the basis of this C, if my C will be the high, if my C will be the high, on the basis of that one, it will be getting, we are getting the output voltage Q bar. If this C will be high, we are getting the output voltage Q, because C is nothing but a load capacitor. Okay, and Q is what? The voltage across the capacitor that will be dependent on the PWM. That will be dependent on the PWM pulse. Now, in the case of PWM pulse, if we provide the PWM pulse, so when one particularly pulse is positive, okay, positive level, that means if the pulse value is 1, so in this scenario, one particularly a gate will be working as a high and another gate will be working as a low. Okay, second, if my pulse will be the negative pulse, that means the lower dimension or zero level, so another particularly gate that previously is the low, now it will be high, and the first one is the low. So on the basis of that one, you are getting a Q and Q bar two different waveforms. Okay, two different waveforms with the respect of Q and Q bar. Now both Q and Q bar waveform will be dependent on the charging of capacitors. So capacitor C value on the basis of C, it will be we are getting the waveform. Now both value will be different. Both waveform is different. So we are like for example with the Q, if I say with the Q, if with the Q, if we say that we are getting a waveform with the Q, we are getting a waveform in this way. Any PWM. Okay. So with the Q bar, if we are getting this one, so with the Q, we are getting this. So where it is a 0, it becomes a 1. Where it is a 1, it becomes 0. Where it will be the 0. Okay, in this way. So just suppose it is. But it is only possible when the capacitor, this C and this C will be the constant. Same. C and C will be the same. If this C will be the C1 and this C will be the C2, and we say the C1 is not equal to C2. So we are getting a different way. In the Q bar, if we are getting this one, so in the case of Q, we are getting a different wave. Why? Because of the capacitor's value is different, we are getting a different charging and discharging. We are getting a different charging and discharging. Okay, so that's why we are getting a two output, that is nothing but a PWM wave with no overlap. Okay, with no overlap. Okay,
Yes, sir. Sir, and what are these NPN, PNP transistors doing?
this one,
Yes,
this
sir,
is
the
the half wave.
transistors.
This okay.
What are they?
So basically, this particularly this transistor is called the pull down transistor. Pull down transistor, and this one is called the pull up transistor. Okay. Like for example, we are getting a QB, Q bar, Q is here and Q bar is here. Okay. So on the basis of Q, my transistor will be working. Okay. If Q is 0, my transistor is working because it is a PNP transistor. So PNP transistor will be work when we are getting a lower voltage, and when we are getting a higher voltage, my PNP transistor will not work. Okay, because it is a N. This is the N terminal. This one is the N terminal. So in the N terminal, if we are providing the lower voltage, my transistor will be on. If we are providing the higher voltage at this N terminal, my transistor is off. Okay, so when I am getting the Q bar and the voltage is Q bar is less, so we are getting a V out here. What is the value of V out? Is VCC. when QP is on, and 0 when QP is on. Okay. Similarly, for the QN transistor, the QN transistor is basically on when QN transistor is on. So we are getting a V out as a 0. V out as a 0. Why? Because when it is on, the V out is connected to the ground. V out is connected with the ground. Or if these two are on, we can say all VCC will pass into the ground. Will also all the VCC will be passed into the ground, and we are getting a V out as a 0. And when QN is off, the V out is 0 or VCC. Both will be possible. 0 when QP is off, and VCC when QP is off. Okay, so that's why these two transistors will be used as a pull-up transistor and pull-down transistor. Okay, so according to the value of Q and Q bar, output voltage is sometimes it is a 0, sometimes it is a VCC, sometimes again 0 VCC. So basically, the polarity is changed. The polarity is changed. 0 VCC, 0 VCC. So at the same terminal, we are getting a 0 voltage, as well as the same terminal we are getting the VCC voltage. Okay. Like we are saying that we are using a two-way H bridge. Two-way H bridge. One is the V out from here, and second V out from here. V out. So when it is a VCC, it is a 0. What is the direction of the VCC with respect to 0? We are saying that my motor will be rotating in this. Okay. In the second case, if VCC and VCC. Okay. So if it is, we are saying that it is a clockwise direction. It is a no motion. Okay, no motion. Why? Because at the both terminal we are getting the same voltage, so my motor will not move. And third case is when it is a V0 and it is a VC. So it is a anti-clockwise. So you can see the polarity of this VC V out one will be changed from VCC to ground, and similarly for the polarity of V out two will be changed from 0 to VCC. Okay, and according to this one, my motor rotation will be changed. Okay, so that particularly a single circuit is called a single edge phase. Single edge phase. In the L293D, in L293D, if you are aware with this IC L293D, we are having a 4 edge phase. Okay, we are having a 4 edge phase. 2 edge will be used for one motor, and 2 edge will be using as a one. So we can connect a 2 motor at a time with L293. Okay. Any doubts? Okay. So you have created this one. Previous part you already created in week 2 assignment. Okay, this triangular wave generator and single-ended differential converter, you are using this particularly part in the second experiment. Now with the second experiment, you connect the third experiment. It's clear?
Yes, sir.
Yes, Abraham. Abraham, are you asking anything?